In this example, what I'm going to do is I'm going to talk about the thin lens equation. Now, I wasn't going to do some ray tracing on some lenses, but I attempted that several times, and I am not a good artist. This school hired me not to teach art, thank goodness, unless it's some strange abstract art. But I cannot draw these things. I've tried several times. So we're just going to go through and do the math. That I can handle doing. So the question reads as such. We have a converging lens which is going to have a focal length of 20 centimeters, and we're going to have an object which is going to be 60 centimeters away from the lens. What we want to do is we want to be able to describe the image. And so the equation we're going to use is the inverse of the distance of the object plus the inverse of the distance of the image is equal to the inverse of the focal length. And we've seen this equation before. And what we're solving for is we want to ultimately solve for the distance of the image. And so the distance of the image is equal to 1 over the focal length minus 1 over the distance of the object. Now we can simply just plug our numbers into this. So we have 1 over distance of the image is equal to the inverse of 20 centimeters minus 1 over the inverse of 60 centimeters. And this will be equal to 3/60 centimeters minus 1 over 60 centimeters, which is equal to now 2 upon 60 centimeters, which is equal to 1 upon 30 centimeters. So that's going to be the inverse of the image. Now, therefore, the distance of the image is going to be equal to 30 centimeters. Now, since this is a positive number, this is a real image, meaning that it can actually be displayed onto a card or onto a screen or something along that line. Now we can determine the magnification of this is equal to the distance of the image divided by the distance of the object and the negative of that. So we plug in our distance of the image, which is going to be 30 centimeters. Don't forget the negative. And then the distance of the object, which is 60 centimeters. And that gives us a negative 0.5. Now, the negative here tells us that it is going to be inverted. So if the arrow is pointing up on the image, it's going to be pointed down. And since this is smaller than 1, the image is going to be smaller than the object. If you have any questions on these equations or on this problem similar to this, please let me know.